Good morning, students. In the last class, we discussed about the preparation of amines. In today's class, we will discuss about the properties of amines. And the physical and chemical properties are there. In that, we are going to study about the physical properties like boiling point, melting point, their solubility, and their acidic and basic character. Okay. So, physical properties of amines. Okay, so in this physical property, first one is as we consider the state means solid, liquid, and gas. Okay, so lower amines are gases and fishy in odor. Lower amines are gases and fishy in odor. Next, amines with carbon atom 3 and above. 3 and more than 3 are liquids. Okay, and next, amines which are still high in number of carbon atoms are solids. So students, here the lower amines are gases, the amines with carbon number 3 and more are liquids, and the amines with maximum number of carbon atoms are solids. For example, RNH2 is the functional group or formula of the amines. If R is 1 and 2, okay, then they are gases. R is consists of carbon atom 1 or 2. Next, if R is consists of carbon atom greater than 3 or equal to greater than or equal to 3, then this is liquids. Okay, so R consists of C atoms greater than 3, more greater than 3, then they are solids. Okay, so these amines are some are color, some are colorless. That is based upon the oxidation of the amines in presence of the air or some other oxidizing agents. Okay, color depends upon the oxidation of the compounds. Okay, students. So this is what state. Next we come to solubility. Solubility or boiling point. These physical properties are very important for 1 mark students. So next one is solubility. Next one is what? Solubility. Okay. So what is the solubility mean? So students, you know, primary amines are there, secondary amines are there, tertiary amines are there. So solubility in water especially or in protic solvent you may say. Okay. So here primary amines means are NH2 type compounds, correct? This one is primary. Secondary means R, NH, R. Tertiary means R, R and R. This is tertiary. We want to study what? The solubility of these amines in water. So water consists of what? The formula H2O. When the given solvent are dissolved in solute, when the given solute is dissolved in solvent is when they form a hydrogen bond. When they form a hydrogen bond. So what is hydrogen bond? The bond formed between two different molecules with the hydrogen and also highly electronegative atom. For example, I will take this RNH2 that is written in this manner. Okay, so water molecule is the HOH. Here also another water molecule is the HOH. So then what happens? Here, this oxygen form the bond with this hydrogen. Okay, next this nitrogen form bond with this hydrogen. Again here also, this one form bond with this hydrogen and this oxygen form bond with this hydrogen. So this type of bond means the force of attraction exerted between this hydrogen and the highly electronegative atom. Hydrogen atom of water with nitrogen, hydrogen atom of ammonia with amines with oxygen. So this is hydrogen bond. So in primary amine, hydrogen bond is possible. Okay. Secondary amine we consider R, N, H, R. Okay. And then if there is no bond, at least one hydrogen bond is there, two R groups are there. So it has the ability to form hydrogen bond, so it is easily dissolved in water. Next, this tertiary consider means there is no hydrogen atom. If there is no hydrogen atom, then there is no possibility of forming hydrogen bond. If there is no hydrogen bond, then solubility is impossible. Okay, here, so if you consider solubility in water, the primary and secondary amines are soluble in water due to formation of hydrogen bond. Okay, whereas tertiary amines are insoluble. This is the example because in primary amine H group is there, in secondary amine H group is there, in H atom is there, in tertiary amine there is no hydrogen atom results in what? Here there is no possibility of formation of hydrogen bond in tertiary amine, hence it is insoluble. Here they form easily hydrogen bond, hence they are soluble in water. So that is the statement. Here in water, the primary and secondary amines are soluble, tertiary amine is insoluble. Okay. Next one is boiling point. So this boiling point also depends upon what? Hydrogen bond. So students, here the primary and secondary amines have high boiling point compared to tertiary amines. Primary and secondary amines have high boiling point compared to tertiary amines. Why? Because, so listen, just now I wrote before, RMH2 type compound means with oxygen or a water molecule, they form hydrogen bond. Okay, two hydrogen bonds are there here. Here, RNHR means only one hydrogen is there, so one hydrogen bond can form. Okay, so in this tertiary means there is no hydrogen bond, so zero hydrogen bond is formed. So when this gets boiled means, so students, when this bond breaks, then this starts boiling. Understand? So here the hydrogen bond is more. So you know the stability of hydrogen bond is comparatively very high. So we require much more force to break this bond. So that's why the boiling point of this is always primary amines greater than secondary amines greater than tertiary amine. So here the boiling point of primary amine is high compared to the secondary and tertiary amine. You remember only this thing. Okay? So this is all about the physical properties. I write a simple note, then you understand easily. Okay, so first you consider state here. The state amines with carbon less than 3, those are gases. Okay, so amines with carbon atom greater than or equal to 3 when they are liquids. Okay, amines with carbon atom very greater than 3, they are solids. This is first physical property. Second one is solubility. So primary and secondary amines, that is soluble. Okay, tertiary amine insoluble. What is the reason? Due to the formation of hydrogen bond. Due to the formation of hydrogen bond. And last one is, that is boiling point. Okay. So boiling point means, students, here. So primary and secondary also. It is primary greater than secondary greater than tertiary. So tertiary has least boiling point and this primary amines has highest boiling point because of the formation of the hydrogen bond. In the physical state, you have to remember only this much. Understand? Okay. So the next one is the basic character of amines. This explains the physical property. Basic character of amines. Okay. So in this basic character of amines, students, so listen, I'll take example of this aniline. Okay, here two lone pair electrons are there. When it is treated with this HCl, okay, then it forms NH3 plus Cl minus. Okay, this is first example. Next, you consider RNH2 plus HCl. Here lone pair electrons are there. Okay, then here it forms RNH3 plus Cl minus. So students, according to Bronsted-Lowry concept, so one which accept H plus ion, that is base. So accept H plus ion. One which donate H plus ion, that is acid. Correct? Here HCl is there, it donate H plus ion, H plus and Cl minus, correct? So here NH3 is there, amines are there, here whatever. So here NH2 is there, this NH accepts hydrogen atom from this acid. Okay, the species which accept H plus ion called as what? Base. Okay, here the amines have the capacity to accept a proton, so acts as a Bronsted acid. So Bronsted bases. And another one thing you have to remember, here lone pair electrons are there. Correct? So this nitrogen have the capacity to donate a pair of electron. Okay, these have the capacity to donate pair of electron. That means they are Lewis bases. Okay, in both the cases, students, by accepting or by donating, by accepting H plus ion, they acts as a base, that is Bronsted base. By donating a lone pair of electron, they acts as a base, that is Lewis base. So in both the cases, these amines are bases. Okay, so what is the main reason for this basic character? Means the presence of lone pair of electron. Okay, the presence of lone pair of electron made these amines and ammonia and ammonia derivatives as Lewis bases. Okay, so in this, I'll take three examples. So ammonia is there, NH3. Okay, aniline is there, NH2, okay, and methanamide, CH3, NH3. Okay, students. So comparing this, which one is more basic? Okay, so ammonia is there, methanamide is there, this one is there. So among these, which one is more basic, which one is most acidic? Okay, so listen, this CH3 group is electron releasing group. Electron releasing group. That means it releases electron towards this nitrogen. Okay, this CH3 releases electron towards this nitrogen. That means electron density on nitrogen increases. Means if you divide this, how you will write? CH3 plus and NH2 minus. Correct? Minus means what? The electrons from the carbon is transferred towards NH2. Correct? CH3 plus and NH2 minus. That minus represents what? The electron from carbon is moving towards this nitrogen. Okay? That means the electron density on nitrogen increases. That results in increase in the donating capacity. Understand? Increase in the donating capacity means this is more basic compared to ammonia. This is basic This is more basic. Okay. Next here it is. If you consider these students as it is a benzene ring, lone pair electrons are present here. Okay. So listen. These electrons, instead of donating to the other atom, they involved in stabilization. Okay. So this will takes place like this. So here one bond, here double bond, and H2 plus here the electron transfer here means this will get minus. Okay. Next, this electron transfer here and this electron transfer here. That means here it is minus charge, double bond, and H2 plus. Correct? So next, these electron transfer here and these electron transfer here. Then, so here bond will form, here by the transfer, here they will form, and this one gets minus charge, this one is NH2 plus. So next structure is so listen, this electron transfer here, again this transfer here. That means we will get NH2 again the lone pair electrons here. So students here, these lone pair of electrons compared to here, they directly involved in the donation. But these lone pair ions in this anilene, they involved in stabilized resonance structure. Okay, that's why this is highly stable. Due to the resonance structures, they become highly stable. So they cannot donate easily these lone pair of electrons. Understand? So that's why this is less basic. Less basic. Okay? So if you know the order, this is more basic, basic and less basic. If you want to write the aliphatic amines. Aliphatic amines are more basic. Or you may write basic method means this is aliphatic amines, this is NH3, and this one is aromatic amines. Okay, so you take this one is more basic, this one is basic. This one is less basic. This one you remember. Aliphatic amines means straight chain compound, R type of compounds. Okay. Aliphatic compounds is more basic compared to ammonia compared to aromatic amines. Aromatic amines means they consist of at least one benzene ring. Understand? So why the reason? Because here they involved in what? Resonance structure. Okay, so students remember in the resonance structure you are getting what? Minus sign here. Correct? Here, here, and here we are getting what? At ortho and para position we have minus charge. Correct? So listen, this is ortho position, this is para position, this is also ortho position. At ortho position we have which charge? Minus charge. Means at ortho and para position they undergoes electrophilic additional substitution reaction. Addition or substitution reaction. Correct? Electrophile means electron loving, means the species with the plus charge, like it may be CH3 plus, NO2 plus, etc. Okay, next except this meta position is there. Correct? So ortho and para negative means meta must be positive. So if nucleophiles are there, those nucleophiles occupy meta position. Understand? So these amine shows electrophilic substitution reaction. Okay? You may substitution you may say or addition you may say. Okay? That is electrophilic substitution only because here hydrogen will be there. That hydrogen is replaced by this electrophile. Okay? So because of the formation of the negative charge in this resonance structure. Okay? It differentially undergoes what? Electrophilic substitution reaction. Okay, so this is all about the basic nature of what? Amines. So here amine, or they may ask the question if they give aniline and at the same time they give methanamine. So in aniline and methanamine, which one is acidic in nature? This one is acidic in nature. Aromatic compounds are always less basic due to the resonance structures. Okay. So now we will discuss about the some important chemical properties of amines. Next one is some important chemical properties of amines. Okay, students. So in the important chemical properties, the first one is acylation. First one is acylation. Next, benzylation. Next one is benzylation. Next, carbylamine reaction. Next one is carbylamine reaction. Next, reaction with nitrous acid. Okay, so the next one is reaction with nitrous acid. So in the types is there, that is primary amine with and with secondary amine or aromatic amine. Okay, while I explaining, I will say examples. Okay, students, this is for what? Aliphatic amines. Next, aromatic, that is specially aniline undergoes acylation, bromination. Okay, next one is nitration. Okay, so and the last one is sulfuration. Okay, bromination, nitration, and sulfonation. This is for aromatic amines. Okay, students, we will discuss one by one now. With what? Acylation of the compound. So, students, what is this acylation? So, listen, acyl chlorides we have to take. Acyl chlorides means RCOCl compounds. RCOCl compounds are called as acyl chlorides. Okay, this R may be CH3 group, R3 group, whatever it may be. Okay, so here what happens? Here this is the acyl group reacts with what? Amines. So I write here reaction. So R N H2. Here lone pair electron is there, correct? So it is reacts with what? R C double bond O Cl. Okay. So then which type of reaction takes place? These lone pair of electron attaches here and this electron shifts here. Understand? This will attaches here and this one shifts here. Then what happens? Write as it is R N H2. Here the bond is formed between what? Carbon. Single bond, carbon, single bond. Here R is there. Here O minus Cl. Understand? This is the reaction. So listen, here for amine, 4 groups are 1, 2, 3, 4 means this is plus in charge. Okay, students? So then after that what happens? This other group, base breakage of bond. That means here they form double bond. Okay, so then they form here hydrogen will remove. Okay, students. Then they form HCl will remove from here. Understand? Okay, this comes here. From here one hydrogen removes. From here Cl removes. Understand? From here one hydrogen removes. From here Cl and here double bond will form. So then it is R NH, correct? Then C double bond O. Then this is R because Cl removed here, H removed here, here double bond is formed. That is R NH double bond O. Here they form amines. This is called the acylation reaction. So the compounds used here is amines and as well as acyl chlorides. Okay, students. This is the reaction. So, here how this acylation reaction takes place. So, when aliphatic primary amine, this is aliphatic primary amine reacts with acyl chloride. This one is acyl chloride. They form intermediate. This one, intermediate. So upon removal of HCl, they form this amines. Okay, so this is the explanation. So this one is primary amine, this one is acyl chloride. Okay, next this one is intermediate, and this one is amide. This is the reaction. So by replacing this R by CH3 group, you may write the example also. And write example here. So here instead of R, I am taking C2H5 NH2. Instead of R, I am taking C2H5 NH2. Plus, instead of R, I am taking CH3 C double bond O Cl. Instead of this, I am taking C2H5. Instead of this, I am taking CH3. Okay. Then the intermediate formula is what? C2H5 NH2 plus single bond CO minus. This is CH3 Cl. Okay. Here these two are replaced by C2H5 and CH3. Then finally, students, here this comes here, this goes up, then we will get AMINES. This is C2H5 NH C double bond O CH3. Okay, so this is the reaction. This is what? Acylation reaction. Acylation. What is meant by benzylation? So here in this acyl group we are taking benzoyl group. Benzoyl means that is benzene ring with COCl bond. That means here our group is C6H5. Understand? If you replace this and if you write that, then you will get the benzyl reaction. Are you getting this? Okay. Next. And write benzylation here. Students, this one is benzylation. So for this benzylation, I am taking this one as an example, that is CH3 NH2. Correct? So benzylation means this acyl chloride is benzoyl chloride. Benzoyl means here our group is C6H5 C double bond O Cl. This group. Okay? C6H5 C double bond O Cl. So then what happens? They form intermediates, that is R means CH3 NH2 single bond C, here C6H5, that is benzene ring single bond O minus, that is Cl. Okay, then if you complete the reaction, you will get CH3 NH C double bond O with the benzene ring. Or I will write this product here, students. That is CH3 NH2 C double bond O with the benzene ring. This is the product we are going to get. So here in the benzylation and acylation, only the thing we are going to observe is what? Here R is different. Here R is primary amine, aliphatic amine, then it is acylation. Understand? If R is aliphatic amine, then this is acylation. If R is aromatic amine here, then this is aromatic compound here in this acyl compound, especially benzoyl chloride, then it is benzylation. Nothing changed, everything is same, students, here. Only the change is in the acylation R is CH3 group. In benzylation R is benzene ring. Understand? That is the difference. So both the reactions are same, that is acylation and benzylation. Okay. So the next one is carbonamide reaction. Next one is carbonamide reaction. next one is used, that is carbon-amine reaction. This is important for 2 marks. Carbylamine reaction. So what is this carbon-amine reaction? Listen. When these RNH2 compounds, that is amines, reacts with chloroform and alcoholic KOH. This is metric alcoholic KOH. Then they form isocyanides. That is RNC compounds. Then they form RNC compounds with KCl and H2O. This is 3KCl because 3 Cl atoms are there. And this is 2H2O. Not 2H2O, this is PH2O. Understand? So here what happens? When these RNH2 compounds react with chloroform and alcoholic KOH, especially ethanol, then they form RNC, that is isocyanides, with the liberation of the byproducts. So this is carbon-amine reaction. This statement is important when primary and secondary amines reacts with chloroform and ethanolic KOH. Ethanolic KOH forms isocyanides. Forms isocyanides. This is called as a carbon-amine reaction. Okay, students. So for this, if you want to write the example, okay. So here R means that is CH3 you take NH2 plus CH3Cl plus 3KOH, that is alcoholic, gives CH3Mc plus 3KCl plus 3H2O. This is for what? Primary amine. Okay. Next, for aromatic, you take this one. Benzene ring with this CH. This is CHCl3 plus 3KOH gives rise to this benzene ring with this cyanide group plus 3KCl plus 3H2O. Okay, the only thing I did here was, students, replacing this R group by aliphatic amine and aromatic amine. So what is the statement? When primary and secondary amine reacts, I said primary and aromatic you take. Instead of secondary, you take aromatic. Okay, so here students, when this amine place, you write the name of this compound. When methanamine reacts with chloroform, in presence of our ethanolic KOH, forms methane isocyanide. Understand? The name of the compound is methane isocyanide. I'm going to write it. Next here. When benzenamine reacts with chloroform in present under ethanolic KOH forms benzene isocyanide. Everything remains same. You have to change name of the amine and the final product here. Here methanamine means methane cyanide, isocyanide. Benzenamine means benzene isocyanide. Okay. So this is the example. The remaining examples we will discuss in the next class.